I'm going to pull out my load bank that I made the other day. You can find the video for it right here. Just click right here and it'll take you to it. Basically what I'm going to do is I'm going to see if these connectors will grab on here. If I were to ever redo this again, I would make all of these connections just jumper wires, or I might solder those types of connectors on the end of one of these alligator connectors, because doing it with all these types of connectors just sucks. So if you're using it, and this will be the second time that I've used it, so I haven't really complained about it that much. So basically what I'm doing is I'm going from the positive rail on this voltage divider over here to one of these resistors, one of these banks of resistors. So these are two 10 ohm resistors wired in parallel, and that's giving me approximately 5 ohms, and that should give us a 2.5 amp output. We'll see if that works out. I'm going to test my resistances here in a second, but let's see. But we may just turn this thing on and blow it up, so we'll see how that goes. I don't know if this is going to add any more resistance into it already being connected like this, but let's just go ahead and see what we got. Hopefully it's somewhere around 5 ohms. Yeah, it's because it's hooked up to the rest of this thing. It's all wired in parallel, and so what we'll do is we'll just double check right here where the actual jumper wires are. So we got 5 ohms. We've got alright, I'm glad I tested it because that was a dead short. So 5 ohms, and we got 5 ohms. So I have basically what's going to amount to a 7.5 amp current draw. I'm not sure if I want to take any current readings. I guess I could for the fun of it. I'm not sure if I have a good fuse in one of these. Let's see. I'm not sure what that reading is supposed to be. I thought it was supposed to be a couple ohms. I'm not sure if I've got any good fuses. Yeah, I think that's right on the 10 amp scale. So what we'll do, this is probably going to go up in flames anyway, but let's see, we'll go ahead and well, they don't want you to get that one off. Let's see if by chance this one's any different. Alright, I'm not going to force those off. I don't want to damage the joints. So let's go ahead and do this. See if we can get this thing to work. Alright, so what I'm going to do is I'm going to go ahead and I'm going to take the leads off each hot leg, and I'm going to, let's see, there's no easy way to do this. was wanting to show the current draw as well too. So here's the circuit that we've got. We've got incoming voltage, outgoing 12 volt DC over here to this voltage divider, and as of right now I don't have a load connected to any of the outputs, and that output from this big transformer going over here to our voltage divider is going through this meter. So we're going to measure the current draw, and I might take some temperature readings. We're gonna see how that goes. Depends on whether I blow some fuses or not. So let's go ahead and power it up, see what we get. So here's a visual representation of what the transformer looks like. That's without any IR applied to the screen. So now let's just take a look and see what's heating up. So it looks like that transformer back in the back and the rectifier. I think that spot right there is a transfier. It's a new product that we're coming up with, is a transfier. I think that's the transformer, and then you got a rectifier, and then I think right over there looks like it's a couple of caps. I could be wrong though. So that transformer is getting up there pretty hot, and same thing with that rectifier. It looks like it's getting pretty warm as well too. It looks like that might be the other transformer. Let me put my finger in there. Oh, it's right there. Looks like that's a resistor in there that could possibly be getting that warm. But let's see. So right now the hottest part, and I'm going to say that that's a resistor or the rectifier. It looks like it's getting up there. This is by no means an accurate test. This is just to give us kind of an idea of how hot this thing is going to get. So it looks like the hottest temperature that we got on there with no load is somewhere right around 110 degrees Fahrenheit. Yeah, and that's that part right there. So, all right, so let's load it and see what we come up with. So I don't have a load on it as of right now. Let's go ahead and just randomly pick one of these circuits to energize. All right, so it's going to be channel 2. Let's see if we can either blow a fuse or get this thing to heat up. I might have a bad fuse in there, or excuse me, I might have a bad fuse in my meter is what I meant. So let's go ahead and unload this. Looks like it's spiking on the current draw, but I would expect that it would actually stay constant. Let's try another channel. I was looking at the voltage too, and I was thinking the reason why I was not seeing a significant current draw was maybe because the transformer is being overloaded and shutting down on its own. So I'm not 100% sure if that's what's going on. So let's load it again and see what happens. That's odd. It's actually increasing in voltage. Okay. Alright, so I guess we'll go ahead and just load all of these down and see what we get. Alright, so there's one of the reasons why I wasn't seeing a voltage sag is because I was measuring it at the wrong point. When I actually go over here to the output of the device, it's got a significant voltage drop. So for the fun of it, let's go ahead and increase the voltage up a little bit, because I'm putting a pretty good load on it. Alright, that's what I want to basically see. Alright, so I'm obviously seeing some kind of current draw, but why I'm not seeing more than what appears to be 10 milliamps, I could be wrong. Maybe I just have it on the wrong range, but I would think that the voltage drop would be a little bit more, or the current draw would be a little bit more significant. I mean, I must have it hooked up wrong, or the fuse is bad in my meter, because my outgoing voltage is 13.9, but when you load it, it drops a volt. So there's obviously some significant current draw there. And when you actually go over here and measure load, let's just check to see what it is at the output. Yeah, so 10.3, 11.2. I am putting a significant load on it, but I'm kind of curious how come it's dropping so low. Again, I'm probably just measuring it at the wrong spot. For the fun of it, let's do this. There obviously is a load on there. Let's go ahead and test this thing and see what the power change has been. So I think that was the hottest spot before, and that was at 110. So it looks like it's jumped up another 10 degrees or so, which is to be expected when it's loaded like it is. It's almost at about 80% of what the load would be. So that's completely to be expected, but it looks like it's just that rectifier that's heating up. Looks like the capacitors aren't heating up at all. And then that one down here on the bottom, that's the transformer, and it looks like that's the rectifier network and the components that are close to it. And again, we'll take a look at that. That looks like it's jumped up 20 degrees or so. I'd imagine you're not going to want to load it as heavy as I have. However, I kind of wanted to push it to the limits and see what it would do. Let's double check what this reading is. So that's not an accurate test of what the temperature would be, but it's close enough. I mean, jumped up 20 degrees at 80-90% of what the rated load is. So the only thing I want to do is I wanted to kind of double check to see why I was not getting a current draw on here, or at least showing a current draw on my meter. I'm probably testing it the wrong way. I just threw this thing together real quick. So let's go ahead and de-energize the power supply. And with those caps, you can see that those caps have quite a bit of energy in them, that they're still lighting that LED and just the inductance and capacitance throughout all of the circuits. So right now it's a good likelihood that there's still some significant voltage on the transformer. So I'm going to be as delicate as I can. Plug this thing back in. And then what I'll do is I'll take one of these loads off. Woo! That little jumper was getting hot. Didn't trip a fuse. Doesn't smell like anything's burnt, but that little alligator connector was hot. So what I'm going to do is I'm going to go ahead and grab onto this connector right here somehow, some way. I don't know if you've ever used these fluke probes, but these aren't what you get just down at the local Radio Shack. These things are substantially thicker, and you can grab on to something without worrying about whether it's going to pull off or anything like that. They hold pretty well, but you can see that they're substantially thicker. I'll put the part number down below. So anyways, got the circuit de-energized. I'm going to take one leg off of one of the output dividers and run it to the meter and then back out of the meter to see what kind of current draw we get. Maybe I was just measuring it wrong. By all accounts, the fuse is reading what it was supposed to be. This is supposed to read between no ohms and half an ohm, and when you're testing the fuse, and it was reading at 200 milliohms. So I'm not 100% sure why I'm not seeing a higher current draw. So obviously I'm testing this wrong, because the alligator clip was hot, and we were seeing a significant increase in temperature on the transformer. So I'm just testing it wrong somewhere around here, because I doubt that it only has 50 milliamps current draw on here. So anyways, let's go ahead and finish this up. Woo! So I went and grabbed the load bank over here that I have. And again, if you want to watch me build it and all the mistakes that I made, you can click on the little video link right here, and it'll take you to it. It was kind of interesting build. I learned a lot of stuff that I didn't want to do, but I just touched the power resistors over here that I had, and it definitely was drawing some current. Let's just see what the temperature is on these. Let me get this in focus. Woo! I think I might have maxed out the power rating on that. I touched those suckers and they were hot. So, do as I say, not as I do type of thing. And I don't know what I'm saying, so don't do any of it. But man, look how hot that thing got. I think I saw 180 degrees.
Woo doggies.
But that's what I made it for, was to be able to test load. I mainly made it for out in the field, but it's worked great here on the bench. I just got to redesign so I don't have to deal with all this junk. And you can see where it really got hot. I'll take a couple pictures of this and see how hot those ends are. So I don't think that was a real world test for the power supply, but I wanted to see what it would do when I put it to its limit, and that came pretty close. You figure each one of these fuses are 3.5 amps, and I think they say amps should be only pushed to about 80 or 90% of what the amp is, or what the rating is. So I think we were pretty close to it, and as you see, the transformer in here got hot and started to actually give a little noise. I don't know if that came across on the microphone. It did get warm as expected, but didn't blow any fuses and didn't smell anything burning or anything like that.